the Pascal identity. N combination R plus N combination R minus 1 will give us N plus 1 combination R for all N greater or equals to 1. So how possible is that? When you see this kind of bracket, it means combination. Okay, so I can have N combination R plus N combination R minus 1. I want to prove that it's the same thing as writing N plus 1 combination R. Okay, so this is N factorial over N minus R factorial, isn't it? Plus N factorial over N minus R minus 1 factorial R minus 1 factorial. When you are doing this topic, this proving, you need to have a very good knowledge of your combination. This side that we're about to prove is N plus 1 factorial over N plus 1 minus R factorial R factorial. I want to prove that these two, it will give us the same thing at both ends. So let's focus on the left hand side. Let's focus on this side. We'll come back to see if it is equal to the right hand side. Let's focus on this side. Now, how do we do that? First of all, let's factorize it. We have N minus R factorial plus N factorial over N minus R plus 1 factorial. Okay, this minus and this minus here. Then I will have R minus 1 factorial. Do you know that this end here, this second one, you can be expressed as this? Let's write it: N factorial over N minus R factorial R factorial. It can be expressed as N factorial R over R factorial into N minus R plus 1 factorial. Do you believe that this R minus 1 factorial can be expressed as R over R factorial? How possible is that? If I have R over R factorial, it's the same as writing R over this R factorial can be the same as R minus 1 factorial. Then this cancels this, so I have 1 over R factorial, which is the same thing as this one. So I can express this whole function here as this other side. Is it clear now? So we'll have let's clear this part so we can have a clear sheet of the board. Okay, now from here I can as well write this as this. I can write N factorial over N minus R, okay, factorial R factorial plus N factorial R over R factorial into N minus R plus 1 into N minus R factorial. How did I do that? If I have N factorial from our basic knowledge is equals to N minus 1 factorial. I'm saying minus 1 from this one, I'll add factorial to it. So same time minus 1 from here, and I add this one. Good. So what I'll do now is to collect like terms. So what can we say that is actually common? We have N factorial to be common, N minus R factorial to be common, then R factorial is common. So I'll have 1 plus R over N minus R plus 1. Okay, good. So if I want to find the LCM of this, it can still be written as N factorial over N minus R factorial into my LCM will be N minus R plus 1. Then I'll have N minus R plus 1 plus 1 in 1. If I add this over 1 in this, I'll still have this plus R. Alright, very interesting. So I can now have N factorial over N minus R factorial into, don't forget that this R here can cancel this one here, so I'll be left with n minus 1 over n minus r plus 1. So we have x n plus 1. Then that's how we have here. Okay, and this is equal to n factorial n plus 1 over n minus r plus 1 into n minus r factorial. Now, do you believe that what this point we have gotten to is the same as what we want to prove? Do you believe that? Let's see if this what I've circled is equal to this part. Let's see if it's actually equal. If I have n plus 1 combination r, which is the same thing as writing n plus 1 factorial, okay, over n plus 1 minus r, okay, factorial r factorial. From our knowledge of n factorial to be equal to n into bracket n minus 1, okay. Now, from our knowledge of this that I've stated earlier here, I can write this as n plus 1 into n factorial, because if I minus 1 from here, this one will become n, over if I minus 1 from here also, I'll be left with n minus r plus 1, then n minus r factorial, then r factorial. You can see that it's the same thing with what I got earlier in the left hand side. So this is equal to this. Okay, therefore this assertion is correct. So that's how to prove the Pascal identity.